All right, what I'm going to do now is I'm going to give you an example of how to use the geometric mean altitude theorem to solve for the altitude in this right triangle. So I have my right triangle with my altitude drawn. The geometric mean altitude theorem states that the altitude is the geometric mean between both parts on the hypotenuse. So what I'm going to do to be successful here is I'm going to look for that altitude, and that's going to allow me to put that in my proportion first. Right, so here I notice my altitude's labeled as x. That x I'm going to use in the denominator in this ratio, and I'm going to use it in the numerator in this ratio. Essentially, I'm using it twice. That's what you're going to hear us say, what piece you're going to use twice. I'm going to use my altitude twice. Whatever's on the altitude is what I'm going to use in the denominator and the numerator in those ratios. All right, the geometric mean altitude theorem is between both parts on the hypotenuse. So in the large right triangle, these are both parts on my hypotenuse, and I'm going to go ahead and plug them in to my proportion. And it doesn't matter where these go as long as they're across from each other. From this moment, I'm going to go ahead and I'm going to solve this proportion by cross multiplying. So I get x squared equal 32, and then we can go ahead and square roots. To get x equals, we're going to go ahead and break that down as a radical to get root 16 and root 2, which would give us 4 root 2. All right. Many times they'll ask for the reduced radical or the decimal form, so just read the instructions. If you're still confused, go ahead and look at it again, but hopefully that helps.